In this first video, we're going to talk about the parallelogram called a rhombus. So because a rhombus is a parallelogram, it will have all of the parallelogram properties. And then what makes it more specifically a rhombus is that it will have four congruent sides. So we can see here's a rhombus right here, and we have 1, 2, 3, 4 sides all congruent. So it's kind of like a square. It just won't have those 90-degree angles like a square does. So our rhombus is like a square, just tilted. So you can kind of think of it that way. So if a parallelogram is a rhombus, then its diagonals are perpendicular. I'm going to use the upside down T to represent perpendicular. Bisectors of each other. So if you have a rhombus, that means the diagonals are perpendicular bisectors of each other. So just a reminder on what that means. Here we have a rhombus. For the diagonals to be perpendicular, what that means is that we will have right angles here at the center. Similar to a kite has that same thing. So that means that angle 1 is going to be congruent to angle 2, which is also congruent to angle 3, which is also congruent to angle 4. And all of those angles are going to equal 90 degrees because, well, that's a weird 9, because they are perpendicular. So we have 4 right angles, all equal to 90 degrees, where your diagonals meet, but they also bisect each other. So that means that they are cutting each segment, or each diagonal is getting cut in half. So AE will be congruent to CE. And then if we look back at the picture, BE will be congruent to DE. So if you have a rhombus, the diagonals are perpendicular bisectors of each other. So another property we have, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. All right, so in this picture, what that means is you have your diagonals. So let's look at this diagonal right here. The opposite angles are this angle, and those are going to be bisected. And those opposite angles are congruent because a rhombus is a parallelogram. So angle 1 is going to be congruent to angle 2 because that got bisected. And then this opposite angle, which is the same size, also got bisected. So angle 3 is congruent to angle 4 and also congruent to angle 1 and angle 2. So angle 1 is congruent to angle 2. That's that angle being bisected, or that's that vertex being bisected. And then those are also congruent to angle 3 and angle 4. All right, so same idea, angles 5, 6, 7, 8. This angle in our rhombus is bisected, cut in half, so 5 and 6 are congruent. This angle over here, these are opposite angles in a parallelogram, so they are congruent. But the diagonal bisects this angle. So we have angle 7 congruent to angle 8, and those are also congruent to angle 5 and angle 6. So we can say angle 5 is congruent to angle 6, which is also congruent to angle 7 and congruent to angle 8.